Okay. I hope you all had a chance to run a few of these code chunks and read in the data and learn already a little bit about the distribution of wealth and income in Basel. Don't worry if you haven't gotten to the end. That's not necessarily the goal. But it's more to, give you the possibility to try these things out and have some exposure to these things. In the practicals to come, there will also be a lot of help, and you're by no means expected now to know all of these things that you've worked on in this practical. There will be equivalent help in the practicals to come, so you should be able to solve everything in the next few practicals as well. Okay, so now you've wrangled the data and you've probably obtained some descriptive results. Obviously, in many cases, it's better, it's more informative, it's more impactful to create visualizations of those data to really see what's going on. And now in this session, we'll be looking into ggplot2 as the weapon of choice to do exactly that, to visualize the data. And so ggplot2 is part of the Tidyverse, and it's really the crown jewel. It's one of the most popular packages in R overall. And for good reason, because it is really an amazing package for data visualization. And it is, the main reason it is amazing is because of its sort of modular structure. ggplot sort of tries to separate the different logical parts of a plot into different components. And that brings with it a lot of sort of power and also a lot of flexibility. So the different components are the data set, then the mapping, which just concerns the basic structure of the plot, then geoms, which concerns how the data is actually illustrated within the plot, labs for labels, themes for aesthetic details, facets for stratifying the plot according to another variable, similar to what group by does in dplyr, and then scales for all of the different scaling. And and having all of these things separated again brings a lot of flexibility. You will see then that we're sort of similar to dplyr chaining, we will now be sort of building up plots one by one. And since all of these things come as their own element, we can simply replace it with something else and thereby change what the plot does. So the goal for this session will be to recreate this plot here, where we have year on the x-axis and income on the y-axis. And we have two lines, one here in sort of a turquoise and one in sort of a light red, showing the income median in the income mean, the averages across all quarters in each of these years. And what you see in this plot is essentially also what you may have already found out based on descriptive statistics, and that is that inequality has gone up, right? So we see that the median has stayed relatively flat, whereas the mean has increased steadily over time, right? This means we are dealing with an increasingly right-skewed distribution, which is consistent with sort of a rich get richer dynamic. All right, let's create this plot step by step. The fundament of every ggplot is the ggplot function, right? And the ggplot function takes two arguments. One is the data, that's the data set we want to work with, and usually that's a tibble. And one is the mapping, defining the basic structure. We don't necessarily need to define both of these arguments. In fact, I think we can run ggplot without any arguments. And here we see that we can run it just providing with the data arguments. So we write ggplot data equal Basel averages. So this is a data frame or a data set that has the averages of income and wealth aggregated across all of the quarters. So it has for every year what the average was across all of Basel. And when we run this, something will already happen. We will see that a plot will pop up in the bottom right of our studio, but it will not show anything. It's just a blank canvas that we've started. So we've started a blank plot by doing that. So then the next thing is that we define the basic structure of the plot. And we do that using the mapping argument. And the mapping argument is specified using a helper function called AES, which stands for aesthetics, which is a function where we define what variables go where. It's basically where we create a mapping of variables to dimensions of the plot. And dimensions of the plot are first and foremost, of course, X and Y, but these can also be color. This can be the opacity of the data. This can be the size or shape, etc. Right? So the cool thing is that for all of these things, we can assign variables, and we will see that soon. And ggplot will automatically then represent maybe the color or the size of the shape according to the variable that was supplied. So here we start easy, and we just assign year to the X argument within AES and income mean to the Y argument. And if we run this, we're one step further. We now see that we have already axes, we have axis labels, and we have grid lines, right? But we don't yet have any data because that's outsourced, or we're not showing any data because that's outsourced in its own sort of logical component or own module in ggplot. Yeah, and in order to control that, we need to come to an operator that's quite similar to the pipe in dplyr, but it's not the same. Technically, in the background, something very different is happening. But in terms of logic or in terms of use, it's quite similar, and that's the plus operator. So when the plus is used within the sort of ggplot, it's not understood as sort of the basic arithmetic plus, but it's the plus of ggplot. And we use it to add additional component to our ggplot. So here we have started with the ggplot command where we define the data and our basic mapping. And now if we want to have the plot show actual data, we need to decide on a geom. In this case, we use a geom point to show us points and add that to the plot. And only then we will see points shown in our plot panel, right? And we see here now the points for income mean, which, as we've shown earlier, right? I mean, do sort of pretty steadily increase across the year. Yes. Yeah, and now the cool thing is there's lots of different geoms, right? I mean, these are just few. We can use geom line to plot lines. We have geom smooth to plot smooth lines. There's bar, box plot, violin, all sorts of different geoms. There's geoms for networks. There's geoms for maps, as we will see later, etc. Right? And they increase as we speak. People are programming new geoms for ggplot all the time and make them available either in ggplot or in helper packages for ggplot, such as the SF package that we will see later on. Yeah, so say we want not represent the data as points, but as line. We just change this one element, this geom, and we change it from geom point to geom line. And now we see the data represented with a different geometric shape, a line in this case, right? We can use geom smooth to show it as a smooth line. This is based on a Löss model, and we also get a confidence intervals by default. Yeah, we can also add multiples, right? Geoms, right? We can add a geom point and a geom line, and then we get points and lines. Yeah, and we can even add additional geoms where we supply different data. So, that's a thing that offers a lot of flexibility. In every geom, you can provide a new mapping and you can provide a new data set. So one way for us to plot separate lines for the mean and for the median would be to just add a second set of geom point and geom line. And within these geoms, we then override the general setting for the y coordinate and set this in these extra geoms to income median. And then ggplot will automatically add a second line for the medians, right? But that's not necessarily the best way to do things. And sometimes you want to program it that way for good reasons, but most of the time you want to actually implement this in a different way. And this is where we have to do a little bit of wrangling, right? And the wrangling we want to do here is to change the data set from a wide format to a long format, right? So if you remember, we don't actually have that here, but originally the data set was just the different years and then two variables, one having the mean of the income means and one having the mean of the income of the wealth means. And what we want to do is change this to a wide format, because then in the wide format we obtain to a long format, because in the long format we obtain a variable that we can plug into our aesthetic mapping, right? So when we change this to long, the data set looks like this. We have a new variable that using the names2 argument we call statistic, and that just carries the name of the variable. So we now have a variable that codes whether we're looking at the mean or we're looking at the median. And we have a second variable that we named using the values2 argument as income that just codes the values, right? So the main reason we do this is that we now have this statistic variable that we can use inside our mapping. We can now use a different dimension of the plot, namely color, and say we want color to be chosen according to this new variable statistic, which is equivalent to saying we want two lines, that one for the mean, one for where statistic carries the value income mean, and one for where statistic carries the value income median. And we also want two lines to be drawn, which is the only way to have different colors for these two kinds of variables, right? So when we have the data set in the long format, we just need to add this little blip here, and we get a plot with two separate lines colored in different ways. Yeah, and then of course we can also choose to represent it differently, right? So I mentioned earlier that we have all sorts of different dimensions in the plot. We not only have color, we have, for instance, shape or opacity. And this is an example with shape, where we assign a statistic to shape within the global aesthetics mapping. And then you see that one line is represented here with these triangles, or the points are represented as triangles, and another line is represented as points. All right. And we could have opacity here, and then we would see that one line would be more transparent than another line. We could have size there, and then we would see size differences between these lines, etc. Yeah, another cool thing that I want to show you, just because it's really an amazing tool for data exploration, is faceting. And faceting is the tool of ggplot where we can create the same plot, but for different, for sort of values of yet another variable, right? So maybe we want to know not what this, the development of the median and the mean is on average. Maybe we want to know what the development is for every individual quarter. And this is where we can use facets. So now we're actually working with the full Basel data set that has been transformed to the long format. And we can now have the same plot structure that we had before. So this was the code for the plot we used for the average data. And now we add facet wrap, where we tell R to separate the plot out or have different facets for each of the different quarters. Essentially, we're saying have the plot distributed, this is what this tilde usually means, according to this variable quarter. And now we suddenly get the same plot for each of the individual quarters. And we can look at it and we see, what we see is that, yeah, for most of the quarters, the trend is actually quite comparable. We see that for most of the quarters, the mean is rising a lot quicker than the median does. All right, so much for the first part of ggplot. So this was about the basic structure of ggplot, defining the mappings, adding geoms, etc. In the next session, we will look at all of the other elements that can be used to make the plot pretty, to add annotation, etc. Yeah, now is again time for you to practice these things. Caught up on time, I think. So you have 21 minutes to try out these ggplot basics and create a similar plot that you've just seen, not with income, but with wealth.